How do tall buildings not fall down? Hi, welcome to Curious Kids Every Day. I'm Josh. How are you doing today? It's so good to hear from you. Hey, have you ever been to a big city that had a lot of big buildings? I'm talking about those huge skyscrapers. Do you know why they're called skyscrapers? Because they're so tall, they look like they scrape the sky. Isn't that crazy? Have you ever done that thing where you stand really close to a huge building and you just stare right there at the wall of the huge building, and then you slowly start to tilt your head up, and you just keep tilting and tilting and tilting until you can see the very top of the building? Some buildings look so big, they seem like they go all the way up into the clouds. It's crazy. Have you ever been to the top of a really big building and looked down? Isn't it amazing that people built something that big? Now, if you're like me, whenever you see a big building, you always wonder, how do these things not tip over or collapse? They've got to be so heavy. They don't even really have legs. They've just got like one leg. The building is the leg. How does the leg stay up? And what happens if the wind blows? Or what if there's a huge storm that comes through? How does the building stay safe? I was thinking about all of this today because I got an email from a curious kid named Ophelia. She wondered, how do tall buildings not fall down? Well, the first big reason is something called the foundation. Do you know what a foundation is? See, buildings, they're not actually built starting on the ground level. If they were, they actually would just tip over. No, engineers dig deep into the earth and build a massive base made of concrete and steel. This base spreads the building's weight over a large area so the ground can hold it without sinking or cracking. Some foundations go down dozens of feet until they reach solid rock. That gives the building something very sturdy to grip onto. Now, when we built the playground in our backyard, this was how we did it. We dug really deep holes. I think we dug holes that were 6 feet deep. And we poured rock into the hole. And then we put the big wooden post into the hole, and it rested on top of the rock. Then we dumped a ton of concrete into the hole. And that concrete gripped onto the rock and onto the beam, and guess what? That wood beam is not going anywhere anytime soon. The next important thing is the actual shape of the building. Tall buildings are designed so their weight is balanced evenly. When the weight presses straight down into the foundation, that building is less likely to tip over. Engineers think carefully about where every wall and every floor and every beam needs to go so that the building stays balanced from top to bottom. Another important part is the frame inside the building. Most tall buildings have a skeleton made from steel and reinforced concrete. Reinforced concrete just means concrete that has steel inside of it. Buildings are always being pushed and pulled at the same time. The weight of the building squeezes the lower parts, while wind and movement gently pull and bend other parts. Think about if you were holding a really heavy rock in your hands. Well, there's a lot of pressure on your feet. Everything is being pressed down. Now imagine that it's really windy outside, and so your body is bending and moving and swaying. See, concrete is very strong when it is squeezed, but it can crack if it gets pulled. Steel is very strong when it gets pulled, and it can handle bending without breaking. By putting steel inside concrete, engineers create a strong frame where each material does what it does best. This hidden skeleton holds the whole building together and keeps it standing safely, even when it starts to move a little bit. Now, what about wind? Wind does push on tall buildings, especially near the top. Instead of fighting the wind by staying perfectly stiff, many tall buildings are designed to sway slightly. This movement is very small and usually not noticeable because the building is so big, but that swaying helps the building stay safe. A little flexibility is better than having a completely stiff, rigid building. Some buildings even have heavy weights near the top, which are called dampers. They move in the opposite direction of the wind to keep the building steady. Some of the tallest buildings in the world can sway several feet at the top during strong winds. But that movement is completely normal. They built the building expecting that was going to happen. Isn't that crazy? But what about storms and earthquakes? Well, tall buildings are designed to withstand those too. Engineers study how forces travel through a building. Then they design the structure to bend without breaking, like we've already talked about. Strong connections between beams and columns help spread forces instead of letting them snap in one place. Force distribution is very important with a building. So, tall buildings stay up because people carefully plan the whole thing out from the very beginning. They plan how the weight moves, they plan how the ground supports it, and how the building responds to wind and motion. Every part works together to keep the building standing tall and safe. Okay, let's have a quick quiz. What part of a tall building is underground and helps spread out its weight? That is called the foundation. And what material is often used to make the strong skeleton inside tall buildings? That would be steel, often combined with concrete. Let's play true or false. True or false? Tall buildings usually sit right on top of the ground with no deep base. False. They've got a really strong foundation under the earth. True or false? A little bit of movement can actually help a building stay safe. Yep, that's true. True or false? Engineers ignore wind when designing tall buildings. That's false. They build it with wind in mind. True or false? The inside frame of a building is more important than how it looks on the outside. Yep, that is true. Would you rather live on the very top floor of a super tall building or on the very bottom floor? I'll tell you what, I would rather live on the very bottom floor as long as I had a friend who lived on the very top floor. That way I could go see those views whenever I wanted, but I still didn't have to take a really long elevator anytime I wanted to leave my house. Okay, let's play a round of What Am I? What am I? I am hidden. I spread out a building's weight, and I keep tall buildings from sinking or tipping. What am I? I am the foundation. Well, the next time you see a tall building, now you know why it's still there. A lot of thinking and testing goes into making sure that those buildings stay exactly where they are. Well, maybe they sway just a little bit. What kind of question do you think we'll ask tomorrow on Curious Kids Every Day? I can't wait to find out. So until then, keep asking questions and stay curious, kids. And we've got a few birthdays today. It's Morgan's birthday. Morgan is from North Carolina, and Morgan is turning 7. Happy birthday, Morgan. Tobias is from Pennsylvania, and Tobias is turning 9. Happy birthday, Tobias. And Wesley is also from Pennsylvania, and Wesley is turning 9 as well. Happy birthday, Wesley. I think maybe those two are twins, but I might be wrong about that. Harper is from Australia, and Harper is turning 7. Happy birthday, Harper. Lola had a birthday this week too. Lola is from Washington, and Lola turned 6. Happy birthday, Lola. Kari is from Rhode Island, and Kari is turning 4. Happy birthday, Kari. For all the grown-ups listening, if your curious kid wants their birthday mentioned on the show, please visit supportcuriouskids.com and join the Curious Kids Club. That's supportcuriouskids.com. See you tomorrow.